Production learning curves. So what are some usages of the learning curve? So estimators can use this information that you gain from a learning curve to determine or estimate how many workers to hire. Of course, there are other factors that go into determining how many people can work on a product. Room. How much room is there? How many people can actually work on this thing at one time? But they can, if they know how many workers can be on it, they can divide the number of estimated hours by the number of workers and kind of figure out what how many hours it's going to take each person. Also, planning budget. They can do a planning budget if they know the labor hours it's going to take to produce end products. They can plug that number into the budget along with all the other costs that they have, and they can use all those costs to set pricing. Set pricing for their customers. They can set price breaks for the customers too. The customer may request a price break at 10 units, at 20 units, at 40 units. Where do they want to be? The client may not be able to pay, for all 40 units. If they're looking for 40 units, they may not be able to pay for all 40 units. So they may want to start off with 10, or they may want to start off with 20, depending on what the price break is. And also, a scheduler can use it for determining how long it's going to take to produce a certain number of products on average. So you can set your labor, you can set your other schedules. In other videos, we'll cover scheduling projects or products, the production process. So you can use these numbers, you can use these estimates and time to set the schedule. There are limitations to the learning curve. If there's a modification to a product, of course it's going to change the learning curve. It can make the learning curve steeper, or it can make it less steep. It depends on the modification. If the product becomes more complicated to put together, it could make the learning curve less steep. So your production won't speed up and won't get fast very quick. It will take a lot longer to get to an optimal production time. So you'll have to produce more to get there. So it's going to take more time underneath the curve and I'll show you an example of that later on. So it'll take you more time, but you can make improvements to the process to increase to better the learning curve, or to make the learning curve steeper. So the steeper the learning curve, the less time underneath the curve, and the less time to get to a more optimal average production time. So also there's industry-derived learning curve rates. These have limitations because they may not be applicable to every workforce, to every part of the country, or to any country. From country to country, they may not be. Some people may be more relaxed in another country than they are in the United States, or we may be more relaxed in the United States than they are in India or China or somewhere like that. So you have to really you have to be knowledgeable about what you're producing and the learning curve and the learning curve data that's available. And these learning curves are really not that helpful with a highly repetitive job that takes short periods of time. If you have something that you're producing, that takes 20 minutes, your learning curve, you're gonna, you may not be able to get that down to, 5 minutes or 3 minutes. So the learning curve would be should be very steep with something so simple. Or you may be at the 20 minutes. I mean, it just may be a product that takes 20 minutes. The motions that it takes to put this thing together or whatever may take 20 minutes. It may have already, you may be able to take your first product and mock product and put it together, and you analyze that based off time studies. You analyze that and go, that's pretty it's pretty much where we are. So you just move from there. So let's look at a learning curve. Let's look at the parts of a learning curve. So here we have a basic graph. Like most any graph, it has a vertical or a vertical or a y-axis and a horizontal or an x-axis. On our vertical axis, this is our processing time per unit. Okay, our x-axis is going to be the units produced. And this is the typical shape of a learning curve. Has a downward slope, which actually tells us that there is a negative relationship between the processing time per unit to the number of units that are produced. Okay, so even though I'm using the term negative, it means that the time actually improves. Your time improves as your production increases. So it doesn't mean negative in the terms of it gets worse. It means the negative relationship means your time is actually improving. Your time is being reduced as you're producing more units. So the assumption under the learning curve, the assumption under the learning curve is your processing time per unit decreases by a constant percentage each time output doubles. So that's what the data tells you. If you go out and you look at industry standard data, it's telling you the learning curve. If the learning curve is 95%, then every time unit 1 is 95%. Unit 2, your learning curve is going to be 92%. To unit 4, your learning curve is going to be 95%. Which is going to tell us that each time we double, when we go from 1 to 2, we're going to cut our time by 5%. When we go to 2 to 4, we're going to cut our time by 5%. So let's look at this real quick. I just want to finish going over the parts of the learning curve and kind of show you the relationship, the negative relationship here. So we're going to start off with unit 1. We're going to draw a line on our curve, or in our graph, to intersect the learning curve. Then we're going to draw a horizontal line to intersect y. And let's assume that our y-axis is representative of days. So we're looking at 8 days to produce unit 1. So what happens when we produce unit 32? What's our average time going to be for unit 2? So if you just kind of look at it, where do you think it's going to be? Is it going to be at 8 units? Let's draw the line here. We draw the line here for the vertical line for 32 units and to see where it's going to intersect the learning curve. Well, we can see that it doesn't intersect the learning curve line and the horizontal line for 8 days. It's lower, it's less, it's closer to 0. So where is that? That's at 2. So what this graph is telling us, what this learning curve is telling us, between unit 1 and unit 32, our production time or our processing time has dropped from 8 days down to 2 days. Now this would be a good size project. This would be a good size product. Okay, this is not, obviously if it's a product that's going to take 8 days to produce the initial one, this is something quite large. So by the time we produce the 32nd unit, our average time should be around 2 days. All right, and as you can see on the learning curve, look at the orange line. You can see that it starts to level out the closer it gets to the x-axis. Okay, so that line is going to almost level out completely, and that is really, that is you're performing at the highest level you can at that point. Again, let's go over this. Okay, so a 95% learning curve represents a 5% improvement rate each time production doubles. Okay. When we're going from Unit 1 to Unit 2, we're going to improve by 5%. 2 to 4, 5%. 4 to 8, 5% is what it's going to reduce. Your time's going to reduce. Okay. At 16, from 8 to 16, we're going to reduce 5%. 16 to 32, we're going to reduce our time by 5%. Okay, so every time production doubles, our time is going to improve by 5%. All right, let's look at the equation for the learning curve. So this is our equation, and what we're doing here is we're trying to figure out the time it takes to do an nth unit. Okay, and in our previous example, we went from 1 to 32. Okay, again, we may need to look at Unit 8 and Unit 16 and Unit 32. So we're going to use this to calculate it, and again, we need to know what the time at Unit 1 is to produce. Or what the time it takes to produce Unit 1. So the equation is T sub n equals T sub 1 times n raised to the power of b. Okay, so again, T sub n is the nth unit produced. T sub 1 is the required time to produce Unit 1, our first unit. N is the cumulative number. Again, that's going to be the 8, 16, and 32. And then we have the 8, 16, and 32 raised to the power of b. Okay. Now again, all right, let me just back up for a second. The n can be any number. I'm just using 8, 16, 32 as an example. So we're going to raise those numbers we're going to raise the n number to the power of b. And the power of b is actually the natural log of r, which is our learning curve percentage. On the previous page or the previous slide, you saw that it was 95%, so it would be 0.95. So it would be the natural log of 0.95 divided by the natural log of 2. B is the natural log of the learning curve in our previous example, 0.95, divided by the natural log of 2. Let's go over that a little bit more. So natural log is log sub e, or the log of e, and e equals 2.71828 ... Okay, so it's a number kind of like pi. Again, we're gonna look at this example of the learning curve of 95%. So the natural log of 95% is whatever it takes it's the power that it takes to get 2.71828 ... to be 0.95 or to equal 0.95. Okay. So that power is actually a negative 0.05129. All right. So again, we're looking at B. So what B is going to be, B is the natural log of 0.95 divided by the natural log of 2, or again, remember we have to raise 2.71828 to a negative 0.05129. All right, so that's going to be our numerator. Our numerator is going to be 0.05129. 0.129, and the natural log of 2 is always 0.69315. Okay, so in all of these equations, the only thing that's going to change in B is your learning curve percentage. All right, so just understand that the natural log of 2 is consistent. It's always going to be 0.69315. So in our case, B, we're going to raise n to B, and B is going to be a negative 0.074. So that's going to be your B for a learning curve percentage of 95%. Okay, so let's look at an example. So Widget X, company Widget X, has been hired to build custom 24 widgets. And it's been estimated that the time to build widget 1 is 15 hours, and that the learning curve is 80%. Okay. The customer has asked for the customer has asked for price breaks at the 6th unit, the 12th unit, and the 24th unit. So how do you know how to add in your labor when you're doing pricing at these milestones or at these intervals? So again, this is our equation. And all we're going to do is we're going to take and we're going to plug our numbers in. All right, so we're going to solve for the average time that it takes to build or to produce the 6th widget. Okay, again, we know our time to build widget 1 is 15 hours. We're looking at the average time it's going to take when we get to the 6th widget. So what we're going to do is we're going to take 15 and we're going to multiply it by 6 raised to B, which is the natural log of 0.8 divided by the natural log of 2. Okay, so moving the process a little bit, the mathematical process a little bit, we have 15 times a negative 0.322, or 15 times 0.5616, or the time to build, average time to build 6th unit is going to be 8.42 hours. So now let's look at the average time for the 12th unit. So what we're looking at here is 15. Now n, instead of being 6, is going to be 12. And again, we're going to raise 12 to the power of b. B is going to be the same number it was for T6. Okay, because we're still looking at the natural log of 0.8 divided by the natural log of 2. We're going to get the same result. Okay, now again, if our learning curve percentage changes, this number is going to change. This number is not always going to be a negative 0.322. It's determined by whatever our learning curve percentage is. So here we are, 15 times 12 raised to the negative 0.322, or 15 times 0.4492. Okay, see, our units went up, our power stayed the same, but the number is reduced. Okay, so that number is reduced to 0.44. It went from 0.5616 to 0.4492. So our time is actually going to go down. So we're looking at the average time at T12 is going to be 6.74. Unit 24. The T1 is still 15 hours. That will never change. N is now 24. B is still going to be the same. B is still going to be a negative 0.322. So we have 15 times 24 raised to the negative 0.322, or 15 times 0.3594, or our average time at Unit 12 is going to be 5.39 hours. So this is how you calculate the learning curve. And you can go in and you can plot these numbers on a curve to kind of get the actual line of the curve. You can continue on until you start to see it flatten out, just in case the client comes back and says, I want to know what we're at 24. Your price is, I'm sorry, we want to know where you are at 48. Where are you at 48? Your price is good at 24. Let's see where you are at 48. And you can take that and calculate it.